Okay, guys, we are now going to transition to population densities and proportions. So this is, again, is one of those fundamental concepts in algebra. You'll see it with similarity. You'll see proportions come up with all circles are similar, and you're coming up with dilation factor. So let's just review what some of those things are. First of all, a proportion pretty much just allows us to compare fractions. It's a way to find a missing number that we need to have. So we use proportions, like I said, for similarity and for missing values. Now, the main concept for proportions is we want to make sure that our numerator matches our denominator. So here, for example, we would have new over old equaling, again, new over old. Here we'd have people over area, miles over hour. We would never have like miles here and then hour up here. You wouldn't have miles per hour and then hours per mile. That'd be going very slowly. So you got to make sure you keep it the same. Whatever's on the top, it's on the top for both of the fractions, and then same on the bottom. Then once you set it up, all we're doing is cross multiplying. So here's an example. A plane travels 500 miles every 2 hours. So in this case, they put the hours on top. It doesn't matter as long as you're consistent. So they put 2 hours on top, 500 miles on the bottom. How long will it take for the plane to fly 2,000 miles? Well, again, we have to match it up. Miles on the bottom, hours on the top, hours on the top. Then all they did was cross multiply, got the answer. Let's take a look at a question. First question, on a 4 meter by 3 meter picnic blanket at 3 p.m., I counted 45 ants. So first of all, then at 5 p.m., there were 85 ants. Now, I don't know why you're staying on a picnic blanket for 2 hours when you have 45 ants and you're waiting for an additional 40 ants to come. I have no idea. I get upset when I see one ant. But apparently, we decided to watch this picnic blanket. So what we're going to do is we're going to first, I like to draw a picture. Our picture is 3 by 4. Now, what makes this challenging is we don't know the area. We have to figure out the area. All you got to do for area, you can look at the formula sheet. It tells you right down here. Area equals base times height. So 4 times 3 is 12. Whenever we do population density, it's always the number of people, or in this case, the number of ants, divided by whatever our area is. So at 3 p.m., wow, that looks awful. That's a 3 p.m. We know that there were 45 ants. So that means we had 45 ants on a blanket that was 12 square meters. Now, ideally, you would reduce this fraction. So all you can do is just do 45 divided by 12, and that gives us 3.75. So there was 3.75 ants per 1 meter squared. And we simplify for a number of reasons. One, once we just know like how much it is per 1 square meter, it's easier to compare, like you're going to see when we look it up for 5 o'clock. The other thing is that most people don't want to do math in their head. So if you say, yeah, there were 45 ants per 12 square meters, they're going to be like, what does that mean? But saying there was 3 ants per meter of my blanket makes more sense. So let's say, then it asks us, what's 5 p.m.? Well, 5 p.m., it's the same idea. We're going to have 85 ants. Our blanket didn't change, so that'll still be 12. So I'm going to do 85 divided by 12 on my calculator and get 7.08. Okay, so you could round that to be 7.1. So now at 5 o'clock, there were 7.1 ants per meter squared on the blanket. That's literally population density. The only thing that you might see a little differently to elevate this problem is asking you to compare the two and say which is greater or less. Okay, so we're back, and let me pull this question back up for us to look at. My students who are in here are being quiet because I'm recording right now, and there's, okay, moving on. So now we're looking at this next question. We've got Joey finds a treasure chest, and that treasure chest is packed. The formula is density equals mass over volume. So the triangle that I was remembering before, I remembered wrong. The D would go in the corner, the mass goes on top, and the V goes on the bottom. So basically all we need to do is we're going to take the mass, which is 16,950, and we're going to divide that by the volume that they tell us, which is 1.5. And that's going to give us our density value. So we've got 16950 divided by 1.5, which gives us a density of 11,300 kilograms. Oh, that's the other thing. That's why it makes sense. Per meters cubed. I was like, that's a huge density, but I didn't realize it was meters cubed. So same thing for population density as I said on the other slide. It's like people divided by area. In this case, we would do mass divided by volume. All right, let's look at a proportion question. You won't see something exactly like this, but I just want to help our minds kind of figure this out. Actually, if I want to make you do it. No, we're not going to do this question. This is more of an algebra question. I was just going to show you proportions on that, so we're not going to do it. Let's just do what you need to know. An equipment manufacturer is planning to bring out a line of exercise equipment. The company conducts a survey by randomly selecting 250 customers. Of the surveyed, 35 said they would get the new equipment. So in this case, we're going to put the new people who like the new divided by all customers. That's kind of how our proportion is. It says in a city of 50,000, how many of those customers would you expect to buy the new equipment? So all we're going to do is say how we do like new over old. This whole idea in this case is how many people like it. So 35 people like it. So that would go in the numerator. Out of how many altogether? 250. And we just set up the proportion. Because the top is our likes, the new equipment, we don't know how many people like the new equipment out of 50,000. That's what we're determining. But we know that our denominator here is going to be 50,000 because the bottom is the total number of people. Now you can cross multiply. I'm going to show you a trick that some people do. Instead of just cross multiplying, and if you did, you would have 250 times x equals 35 times 50,000. That's the long way. Here's the short way. The short way is all you got to do is figure out what do you multiply 250 by to get 50,000. And to do that, we're just doing 50,000 divided by 250, and that's 200. So if we didn't multiply the denominators, it's called equivalent fractions. It's like a 6th grade skill. If we multiply the denominators by that 200, that means that we also have to multiply our numerator by 200. So I've got 35 times 200 and get 7,000 people would expect to buy it. So this manufacturer, he wouldn't want to make 20,000 pieces of equipment. He'd want to make somewhere in the neighborhood of 75,000 if the ratios stay the same. Next. Alana can build 8 computers in 13 hours. So we've got computers, 8C over 13 hours. Sage can build 10 computers in 16 hours. Who's fastest? So all we're going to do is actually just get the decimals. 8 divided by 13 tells us that on average, Alana can build 0.61 computers per hour. And 10 divided by 16, 0.625 is what Sage can build. So because of that 0.014 difference, Sage can build computers faster. That's a very interesting letter S. A study reports that in 2010, the population of the United States was 308,745,538 people. The land area was 3,531,905 square miles. Based on the study, what was the population density? And look at how nice they are. They even tell you. People goes on top, per, divide sign, mile goes on the bottom. So all we're going to do is, anytime you see per, that means divide. That pretty much tells you what the proportion is that you need. So we've got all those numbers, 308,745, 538 people divided by 3,531. The good news is if you had this question on your test, you'd probably just type it right into the calculator and not have to write it all down. That's our area. Miles squared, and now we're going to type in the calculator. 308 745 538 3 531 905. And that gives us, it says to the nearest tenth, so it actually is 86.56. So because this number here is 5 or higher, we have to round up. So we're going to have 86.6 people per square mile, which doesn't sound like a whole lot, but if you think of like the vast mountains where there's hardly anyone living, it does make a whole lot of sense. Okay, next. The population of Orchard Hill is 360 people. The length of each block is the same as the length of the length of each block is the same, comma, and the length of 20 blocks is 1 mile. If the area of Orchard Hill is 4 by 3 blocks, what is the area in square miles of Orchard Hill? Isn't that curious? Okay, first we have to figure out, you won't have a question like this exactly because you don't have to know miles in here, but there is 5,280, right? 5,280 feet per mile. Well, we don't even really, well, yeah, we do. Actually, you know, you don't even have to go into that. You could just take 1 mile and divide it by 20, and that tells you that 1 divided by 20, I think, is 0.05, but my mind is a little off. Yeah, so we know that 1 block, we know that 1 block is 0.05. The other thing we could have done is we could have done it this way. We could have, so then we wanted, so now we know it's 4 by 3. So that means we're going to take 4 blocks by 3 blocks is 12 blocks. And then you're just going to multiply these numbers together. So that will give you 0.6. Let me show you the better way to do it, because that was my just cheating way of doing it. We should have done, there's 20 blocks in 1 mile. If we have, let's say, 12 blocks, how many square miles is it? And that's how we should have done the problem, but that works too, 0.6. So that would have given us 20x equals 12. Divide both sides by 20 and you would still get 0.6. What is the population density of the neighborhood given as the number of people per square mile? So now we're going to do population density, remember, is people over square mile. So we've got 360 people who live in 0.6 miles. So that's it, 360 divided by 0.6. That gives us 600 people per 1 mile is your answer. Yeah, and that's it. Yay, us.